We're going to continue our discussion of limits, but today we're going to talk about finding them analytically, which means algebraically, and the steps that we're going to use to find them. So the first few are relatively simple as we're looking at basic limits, and we'll start with this one right here. So this says the limit as x approaches c of some constant function, that's just going to be whatever the constant is. So if we look down at the example right here, the limit as x approaches 2 of 3, the limit of 3, as x approaches 2, that would be a horizontal line, so that y coordinate is going to remain constant and be a 3. This one says the limit of x as x approaches c, we're just going to plug c in for the x, and it's going to be whatever that value is. So the limit, if we look at now this one right here, the limit of x as x approaches -4, I'm going to plug in -4 for the x, and that would be the y coordinate would be -4, and that would be the identity line. So we know the x and the y are the same. In the last one here, in the basic limits, we have an exponential function, so the limit of x raised to the n as x approaches c. All we're going to do is plug in the c and raise it to that power. So if I'm looking at the third example here, that limit, I'm going to plug the 2 in and square it, and the limit would be 4. And again, that would be the y coordinate on that particular graph. In the properties of limits, this is basically saying that we can multiply limits by a scalar in this particular one, or we can take that out and then calculate the limit. In this one, it's saying if I have a sum of two limits, I could find them individually and add their results together. Same thing with the product, same thing with the quotient. And here I could also work with the exponential. And I'll be working with these properties as we move on and work through. But what we're working on right now is your very first strategy when you look at a limit approaching a constant is you're going to ask, can I plug it in? And if you can plug it in, that means that the limit is going to be at a point on our graph. So if I go down to this one right here, I can plug in and so when I do that, I get 4 times 3 squared plus 3. Oops. Sorry, I'm plugging in a 2 there. So it's going to be 4 times 2 squared plus 3, and that's going to be 19. So the limit is 19, and that 19 is actually the y coordinate of that point on the graph. So when we're looking at polynomial functions, this strategy says you're going to plug in the constant when you do that. And same thing for the rational function. We just need to make sure that that value is defined when we want to plug it in. So if we look at our example down here, find the limit, I want to see if I can plug in the 1. And so I look down here. The value that makes this undefined is -1, so I can plug in the 1. So that's going to look like this. 1 squared plus 1 plus 2 all over 1 plus 1. So everywhere I saw an x, I plugged in the constant. That's a 4 over 2. And so my limit would be a 2. And again, because I was able to plug it in, that would be the y coordinate of the point on the graph. Okay, same thing holds, constant holds with a radical, and you again have to take in domain if our index was even. So here, what we're doing, same thing like the polynomial, you're just going to plug it in and evaluate the square root. Now, your assignment for today is basically there are 3 things that we're going to do. And so we're going to look and evaluate each limit. And so we're going to do direct substitution first. That's our first strategy. So as I'm looking at this first problem, I look to see, can I plug in a -3? And I can't. So can't plug in -3. So that's our first step. So if that doesn't work, then we're going to continue to use the limit notation. So limit as x approaches -3. But what I'm going to try to do now is factor. So the top would be x plus 3 times x minus 2 over x plus 3. And the x plus 3's will cancel. And that leaves me with the limit as x approaches -3 of x minus 2. And now, based off what's left, now can I plug in the -3? I can. So -3 minus 2 is -5. So that would be our limit. And the limit, this occurs, the limit is at a hole, at a puncture hole, or a removable discontinuity, because we factored it in, we canceled. So if you plug in directly, it's the y coordinate. If you factor and cancel, the limit would occur at a point on the graph. All right, now let's look at this next one here. Let's see. All right, so the limit as x, the limit of x plus 1 over x minus 1 as x approaches 0. So your first step is plug in 0. So I can plug in 0. We could use a quick cover up there if we want to, or if you want to see it written out, this would give us -1. And you do not need to carry the limit notation once you plug it in. And again, this is a point on the graph. You do not have to write that. I'm asking you for what the actual limit is, but I just want to keep referencing that so you can see what we're doing and why that's important. Okay, this next one. All right, here we go. So I can't plug in 0. I can't factor and cancel. So the limit doesn't occur on a hole. It doesn't occur as a point on the graph. So now what I'm going to have to do is work on this algebraically. And the radical is a little bit different situation, and I'm exposing you to this because in both levels of calculus, you're going to have to learn how to do that. So I thought we'd take a look at it right now. So what we're going to do, and this is going to be a little bit weird, but I think you'll see the point here in a minute. We're going to multiply top and bottom by the conjugate of the numerator. So remember, the conjugate would change that connecting sign to a plus, and then over, and the connecting sign to a plus. Okay, now what we're going to do is take the algebraic steps to see where this leads us. Notice, keep the limit notation coming. I'll be watching for that. And now multiply. Radical times itself is the radical. These are conjugates, so the middle terms will cancel. And that's going to leave me with -1 all over. Now down here, make sure we leave it intact. Okay, we don't want to distribute, cancel yet. We want to leave that as it sits and see what happens. So now on the top, a 1 and a -1 is a 0, so that's an x over x times the quantity, x plus 1, and then plus 1. And remember here, probably a good idea to put parentheses around this so that we don't get confused. Okay, now what happens? Those cancel. So limit as x approaches 0, 1 over square root x plus 1 plus 1. Okay, now plug in your 0. So I don't need the limit notation anymore. 1 over square root 0 plus 1 plus 1. And that's going to give us 1/2. And again, I was able to plug in the 0 after a little bit of algebraic manipulation, so that would also occur with a point on the graph. If you couldn't simplify like we did, we had to do some algebra work, we might have to do the one-sided limits from a graph, and we'll look at that once we get into limits at infinity a little bit later on.